Good afternoon, student. Dear student, in previous lecture, we have completed three types of question on chapter wave optics. First type is MCQ, second type is very short answer, and third type is short answer type first. Today we are going to solve the short answer type second. Question number first. Explain the reflection of light at a plane surface with the help of a net ray diagram. First, we have to draw the diagram, net ray diagram. Okay. Therefore, with labeling, XY is the plane reflecting surface, AB is the plane wavefront, then RB1 is the reflecting wavefront, A1M B1N is the normal to the plane, then I is the angle of incidence and R is the angle of reflection. Here we have to prove the angle of incidence is equal to the angle of reflection, and we have to use the wave theory of light. This is the law of reflection. You know this very well. Okay. We have to prove this law using the wave theory of a light. Therefore, explanation. A plane wavefront AB is obliquely incident on the surface XY. Okay. Then when A reaches the XY at A1, then the ray B reaches the point B and it has to cover the distance PB1 to reach the reflecting surface XY. Let T be the time required to cover the distance PB1. During this time interval, secondary wavelets are emitted from A1 and will spread over the hemisphere of radius A1R in the same medium. Distance covered by the secondary wavelets to reach from A1 to R in time T is the time as the distance covered by the primary waves to reach from the P to the B1, and therefore A1R is equal to the PB1 is equal to the CT. All the rays between the A1 and BB1 will reach XY after A1 and before B1. Hence they will emit the secondary wavelets of decreasing radii. Okay. Then the surface touching all such a hemisphere is RB1, which is reflected wavefront bounded by reflected rays A1R and B1Q. Then draw the A1M perpendicular to XY and B1N perpendicular to XY. Thus, angle of incidence is angle A1M is equal to the angle B1N is equal to the I, and angle of reflection is angle MA1R is equal to the angle NB1Q is equal to the R, and therefore angle RA1B1 is equal to the 90 minus R, and angle PB1A1 is equal to the 90 minus I, and therefore the angle of incidence is equal to the angle BB1N is equal to I, and angle of reflection is angle MA1R is equal to the angle NB1Q is equal to R, and therefore angle this RA1B1 is equal to 90 minus R, and angle PB1A1 is equal to the 90 minus I. Okay. Then in triangle A1RB1 and triangle A1PB1. Therefore, in this triangle, these two angles are congruent angle, angle R and angle P, and A1B1 is equal to the A1B1 is the common side, and therefore we can say that angle A1RB1 is congruent to the triangle A1PB1. Therefore, these two triangles are congruent, and therefore we can say that angle RA1B1 is equal to the angle PB1A1. And therefore, what is the value of angle RA1B1? It is the angle 90 minus R. And what is the value of angle angle PB1A1? It is 90 minus I. Therefore, 90 get cancelled and we get the I is equal to the R, and therefore angle of incidence is equal to the angle of reflection. This is the law of reflection. Okay, again the incident rays and reflected rays and normal lie in the same plane. This is the law of reflection also. Then second question, describe Young's double slit experiment with a net diagram showing the points of maximum and minimum intensity. ओके, आता इथे जी डायग्राम झालेली ती थोडी टीडीएस वाटते आपल्याला, परंतु आपण जी घेतलेली आहे नोटबुकमध्ये ती आणखी सोपी आहे. ती डायग्राम काढली तरी चालेल. आणि दाखवताना इथं नंबर ऑफ आपण काय दाखवलेले आहे, क्रेस्ट आणि थ्रस्ट दाखवलेले आहेत. ते जर तुम्ही कमी दाखवले तर तुम्हाला तो पॉइंट्स काय होणार आहे, आणखी क्लिअर होणार आहे. ओके, देअरफॉर डायग्राम इज व्हेरी इम्पॉर्टंट. एस इज हिअर द सोर्स, S1 and S2 are the two coherent sources. A and B is the first screen and P and Q is nothing but a second screen. Okay, and here we get the maximum and minimum point. Maximum point means we get here the maximum displacement, and this is nothing but a bright bands, and minimum displacement at this point we get the dark points. Okay, therefore in Young's double slit interference experiment, a plane wavefront is made to fall on the opaque screen to similar to the narrow slits S1 and S2. की AB स्क्रीनवर काय आहेत तर दोन आपण नॅरो स्लिट S1 आणि S2 घेतलेले आहे. द फिगर बिलो above shows the cross section of experimental setup, and the slit have their length perpendicular the plane of the paper. The slits are about the 2 and 4 mm apart from each other. ज्या काही दोन स्लिट्स आहेत त्यांच्यामधलं जे काही डिस्टन्स आहे ते अतिशय काय असतं, स्मॉल असतं. इट इज 2 to 4 mm apart. Okay, then observing screen PQ is placed behind the AB. Assuming that the slit S1 and S2 are equidistant from the slit S, and the wavefront starting from S and reaching the S1 and S2 at every instant of time are in phase. When the rays fall on S1 and S2, the two slits acts as secondary source of light, emitting cylindrical wavelets with axis along the slit length to the right of AB. The two secondary sources emit the two waves which are in phase. The crest and or thrust of secondary wavelets superpose as shown in figure and interfere constructively high intensity, giving rise to a bright band. When the crest over crest and thrust over thrust असतील, म्हणजे दोन वेव्ह जर ह्या इन फेज असेल तर वी गेट द हाय इंटेन्सिटी ॲट दॅट पॉईंट, वी गेट द हाय डिस्प्लेसमेंट, मॅक्झिमम डिस्प्लेसमेंट, अँड ॲट दिस पॉईंट वी गेट द ब्राईट बँड. When crest of one wave coincide with the thrust of other, causing the zero intensity, dark images of these slits are produced on the screen PQ. And when the crest over crest or thrust over thrust असेल तर these two waves are in phase. When the crest over thrust असेल or thrust over crest असेल तर two waves are out of phase, and therefore we get the minimum displacement, minimum intensity, and that point appear as a dark. Okay, the dark and bright regions are called as a fringes, and the whole pattern is called as a interference pattern. Okay, therefore we get here the interference pattern. In interference pattern, central bright band is a central band is always a bright band, and then there is a alternate dark and bright bands. Okay, then question number 3. Explain experimental setup for Fraunhofer diffraction with a neat diagram. इथं आपल्याला फक्त एक्सपेरिमेंटल सेटअप काय करायचं आहे तर एक्सप्लेन करायचं आहे. Therefore we have drawn this diagram first. Okay, then in this setup of Fraunhofer diffraction has monochromatic source of light S at the focus of a converging lens. Ignoring aberration, the emerging beam will consist of plane parallel rays resulting in plane wavefronts. These are incident on diffraction elements such as a slit, a circular aperture, a double slit, a grating, etc. In the case of circular aperture, S is the point source and the lens are the biconvex lens. For linear elements like the slits, grating, etc., the source is linear, the lenses are cylindrical in shape so that the focus image is also linear. Okay, therefore this is the experimental setup of Fraunhofer diffraction. An emerging beam is an incident on another converging lens that focuses the beam on a screen. Okay, now next is the problem. The distance between two consecutive bright fringes in a biprism experiment using the light of wavelength 6000 angstrom is 0.32 mm. By how much will the distance change if the light of wavelength 4800 angstrom is used? Here we have given the two wavelength of light. First one is the lambda 1 is the 6000 angstrom. Therefore convert it into meter, 6 into 10 raised to minus 7. Lambda 2 is the 4800 angstrom. Therefore convert it into meter, 4.8 into 10 raised to minus 7 meter. Okay, then what is the 0.32 mm? 0.32 mm is the distance between the two consecutive bright fringes. त्याला आपण W1 म्हटलेला आहे फ्रिंज विड्थ और ब्रँड विड्थला. Therefore it convert it into meter, it is 3.2 into 10 raised to minus 4 meter. Okay, then the distance between two consecutive bright fringes, formula is W is equal to the lambda d upon d. Write down this equation for the two wavelengths. Therefore we get here the two equation. This is the W1 and this is W2. Okay, then in this case we have to find out the value of W1 minus W2. ज्यावेळेस वेवलेंथ पहिल्या वेवलेंथला आपल्याला फ्रिंज विड्थ 0.32 मिळालेली आहे. दुसरी वेवलेंथ जर चेंज केली 4800 आहे जी वेवलेंथ, तर त्यावेळेस मग काय असणार आहे, फ्रिंज विड्थ किती असणार आहे आणि ती कितीने चेंज होणार आहे. देअरफॉर वी हॅव टू फाइंड हियर W1 मायनस W2. ओके, फर्स्ट वी कॅल्क्युलेट द W2. ओके, W2 कॅल्क्युलेट करण्यासाठी आपल्याला दोन्ही इक्वेशनचं काय घ्यावं लागणार आहे तर डिवाइड करावं लागणार आहे. देअरफॉर इक्वेशन 2 अपॉन इक्वेशन 1 गिव्स here lambda 2 upon lambda 1, and therefore here we gives the W2 is equal to the 2.56 into 10 raised to minus 4 meter. Therefore W1 तुम्हाला माहित आहे W1 is equal to the 0.32 mm आहे. W2 किती मिळाले आपल्याला 2.56 into 10 raised to minus 4 meter. Therefore subtract it and we get it 0.064 mm. Okay, now next is again the problem. A parallel beam of green light of wavelength 546 nanometer passes through a slit of width 0.4 mm. The intensity pattern of the transmitted light is seen on a screen that is 40 centimeter away, what is the distance between the first order minima? Okay, here lambda is given. Lambda is equal to the 546 nanometer. Convert it into meter. 546 into 10 raised to minus 9 meter. A is the width, slit width is the A is equal to the 0.4 mm. Therefore, it is 0.4 into 10 raised to minus 3 meter. Okay, now capital D is the 40 centimeter. What is the distance between the two first order minima? The distance between the two first order minima, it is equal to the width of the central maxima. म्हणजे दोन फर्स्ट ऑर्डर मिनिमा इज इक्वल टू द काय असणार आहे, विड्थ ऑफ द सेंट्रल मॅक्झिमा. आणि विड्थ ऑफ द सेंट्रल मॅक्झिमा इज WC is equal to the 2 lambda d upon A. Therefore, it is straightforward. Put all this substitution and we get it is 1.092 into 10 raised to minus 3 mm, and therefore we get the distance between the two first order minima is equal to the width of central maxima is equal to the 1.1 mm. Okay. Then next one is in Fraunhofer diffraction by narrow slit, a screen is placed at a distance of 2 meter from the lens to obtain the diffraction pattern. If the slit width is 0.2 mm, the first minimum is 5 mm on the either side of central maximum. Find the wavelength of light. Here capital D is the 2 meter. Okay, screen is placed at a distance of 2 meter. Then y1d is equal to the 5 mm. Therefore, it becomes in meter 5 into 10 raised to minus 3. A is the 0.2 mm. Slit width is A is the 0.2 mm. Therefore, convert it into meter. 0.2 into 10 raised to minus 3 meter. Therefore, it is 2 into 10 raised to minus 4 meter. Therefore, YMD is equal to the M into lambda D upon A. And if you put all this substitution, we get the value lambda is equal to the 5000 Armstrong. In this way, you can solve the problems depending upon the wave optics. Okay. Then next, explain constructive and destructive interference with the help of a diagram. Here we have to explain the constructive interference and destructive interference with the help of a diagram. डायग्राम आपण इथे दाखवलेले आहे की कन्स्ट्रक्टिव्ह इंटरफरन्स केव्हा आपल्याला मिळणार आहे, डिस्ट्रक्टिव्ह इंटरफरन्सची काय कंडिशन्स आहे हे तुम्हाला माहीत आहे की व्हेन द टू वेव्स आर इन फेज we get here the constructive interference, and when the two waves are out of phase we get the destructive interference. Okay, therefore constructive and destructive interference, points where the crest of one wave coincide with the crest of another wave and where the crest of one wave coincide with the crest of another wave are the points with maximum displacement. At this point, displacement is twice that for each wave, and these points are called as constructive interference. की ज्यावेळेस क्रेस्ट ओव्हर क्रेस्ट असेल आणि थ्रस्ट ओव्हर थ्रस्ट असेल, इथं आपण फिगरमध्येही दाखवलेलं आहे, त्यावेळेस ते पॉईंट्सला इंटेन्सिटी ही मॅक्झिमम असेल, डिस्प्लेसमेंट मॅक्झिमम असेल, आणि वी गेट द कन्स्ट्रक्टिव्ह इंटरफरन्स. ओके, देन नेक्स्ट, पॉईंट व्हेअर द crest of one wave is coincide with the crest of another are points with the zero displacement, and these are the points of destructive interference. ओके, म्हणजे ज्यावेळेस एका वेव्हचा क्रेस्ट आणि दुसऱ्या वेव्हचं थ्रस्ट हे कोइन्साइड होतील त्यावेळेस आपल्याला काय मिळणार आहे, मिनिमम इंटेन्सिटी मिळणार आहे, मिनिमम डिस्प्लेसमेंट मिळणार आहे किंवा झिरो डिस्प्लेसमेंट मिळणार आहे, झिरो इंटेन्सिटी मिळणार आहे. दीज आर द पॉईंट्स ऑफ डिस्ट्रक्टिव्ह इंटरफरन्स. Therefore, in this way, you can solve the short answer type second. Thank you.